Let's review for quiz 6c. Number 1 says write each expression in exponential form. Exponential, we want exponents. So remember that this number right here, the 3, is a root index. That's going to be the denominator of our rational exponent, the exponent. So you've got 7x to the 1/3 power. And that's it. Okay, that's all there is to it. Now, if, for instance, you had that same problem, but there was like a number out here, like a 2, that would be the numerator. So it'd be the same thing. You'd have 7x here, and you'd have the denominator, but now you'd have an exponent, or you'd have a numerator. Write each expression in radical form. Radical form, we want that symbol. It's not called a square root symbol unless it's a root 2. It's called a radical. But again, you're looking at that denominator, so now we work backwards. That denominator is the root index. But then the numerator is going to be that power. If that was a 1, we wouldn't need it there. So if we had 7n to the 1/2, then that would just be the square root. That would just be the square root of 7n. Also, by the way, we don't really need that 2 right there when it's a square root. We could just say this. It's not wrong if you put the 2 in there, but that's the only one that's not necessary. Simplify. In order to simplify, we want to change it back to radical form. So that denominator 5 means this is a 5th root. 5th root of 32a to the 5th. Now the best thing you can do is if you just know the 5th root of 32. If you know the 5th root of 32, great. Sometimes if it works out nice, you can put it in on a calculator. If I go 32 to the thing is, you'd need parentheses around your fractional exponent. That's the 5th root of 32. 5th root of 32 is 2. Okay, so that's good. If you didn't know that, we could break it down like this. Divide by 2, divide by 2, divide by 2, divide by 2. It's 2 to the 5th. 32 is 2 to the 5th. So if you do it like that, I kind of like doing it like that, because then the numbers act exactly the same way as the variables. And with the 5th root of 2 to the 5th, so 5 goes into 5 one time, comes out. 5 goes into 5 one time, comes out. That's your answer. 5th root of 32 is 2. 5th root of a to the 5th is a. If there was a numerator, then you'd have to square it or cube it or whatever. All right. So, if that was 32 a to the 2/5, then it'd be the same thing, 2a, but then you'd have to square it because that's the numerator. So 2 squared would be 4 and a squared right there. Okay, now that's not the problem. That's not the problem. That's just an extra example. Number 7. You get the cube root of 64a cubed. Now again, if you know the cube root of 64, great, you can write it down. If you don't know the cube root of 64, then you can break it down. 64. Divide by 2, I get 32. Divide by 2, I get 16. Divide by 2, I get 8. Divide by 2, that's 4. Divide by 2, that's 2. So 1, 2, 3, 4, 5, 6. That's 2 to the 6th power. 64 equals 2 to the 6th power. So we've got the cubed root of 2 to the 6th, a to the 3rd. 3 goes into 6 twice, so that's going to be 2 of the 2's. And 3 goes into 3 once, so I bring an a out there. Nothing stays in. 2 squared is 4. I get 4a. Now again, the fastest way to do it, if you knew the cube root of 64 was 4, because 4 times 4 times 4 is 64, then great, you can skip a step. Again, if there was a numerator there, If that was a 2, you'd square it. If that was a 5, you'd take it to the 5th power, or whatever it says. Solve each equation. Okay, remember we want to isolate the radical. And a lot of the times there's going to be like a square root of something plus 4 equals, 10 or whatever. We'd have to subtract that 4 over to get the radical by itself. You'd want radical equals 6 or whatever. All right, that's not part of this problem. This problem is already isolated. You've got this square root by itself already. So what do we do to get rid of the square root? We square both sides. We're going to square both sides, and that makes the radical go away. 2 squared is 4. So we isolate the radical, we square both sides, and now we isolate the variable. I'm going to add this one. So that says opposite of A equals 5, and I can divide by -1 to get A equals -5. Now, when it says check for extraneous solutions, sometimes your number doesn't work. And so it's a little bit weird. So technically, we're supposed to check our answers. You check your answer by plugging in. So if we plugged in -5 right there, we'd have the square root of -1 minus -5 equals 2 question mark. Okay, we're trying to see if that works. Well, minus minus is going to be plus plus. So -1 plus 5 is 4. Square root of 4 equals 2. Yeah, that's true. So this works. Every once in a while, you'll find one that doesn't work. Number 11, we're going to square both sides. And normally we want to isolate the radical first, but that's technically already done for us. So let's square both sides. And square root squared cancels out. So n plus 7 equals 4n plus 1. I want to solve this by getting my variables together. Usually what you want to do is knock out your smaller variable first. I think that's the most efficient way. So 4n minus n is 3n. I'm going to iso the variable now, so subtract 1. 6 equals 3n, divide by 3. N equals 2. So we think that's the answer, but we need to check just to make sure. Sometimes they don't work. So you're going to plug in a 2 right there and there. Feel free to do this in your head if you want, or skip steps if you want. I've got square root of 2 plus 7 equals square root of 4 times 2 plus 1, question mark, because we don't know. That's square root of 9, which is 3. And that's square root of 8 plus 1, that's square root of 9, which is also 3. So that checks out. That means our answer is right, and it works.